All right. So, let's take a look.
Why did you not show up at school today? We are very disappointed in you.
Be nice. Like, hey Jonah, we're courageously pressing forward without you. This is 5J, right?
Yes.
Okay, good. Calling this up. Yikes.
What do you do Thursday and Friday?
Alright.
It's like good one.
Number one. The only thing we needed for number one was the exact area. It was 45 over 2, otherwise known as 22.5. The exact area for, here we go again. X squared over 2, pardon me for a second. Minus x plus 1. So, from 1 to 6, 5 chances. Oh wow, hang on a second. That was goofy. X squared over 2, minus x plus, oh, x plus 11. Okay. Try it again. No. This is 1 to 6. This is a long way around just for the single answer. The exact answer is 23 1/3. Was known as 70 over 3 for number 2.
Oh my god.
For number 3, let's type this in. Negative x squared over 2 plus 6.
There's we got a negative number, so
2, 5 slices. I think I typed that in incorrectly. Hang on a second. Negative x squared over 2 plus 6. Yeah, I did that right. I came up with 24 and 1/6 for the exact area of number 3. Number 4, let me do a new thing here. X squared plus 2x plus 2. Plus 2. It would be nice if the computer actually gave me answers for these things once in a while. From negative 4 to 1, 5 slices. Okay, they're as follows. The upper sum is 24. The lower sum is 11. Trapezoid sum is 17.5, or 35 over 2. Midpoint sum is 16.25, or 65 over 4, I think. And Simpson's rule is going to be 16 2/3, otherwise known as 50 over 3. And exact answer is 16 2/3, or 15 over 3, or 50 over 3.
Yeah, that's
Okay. Number 5, let me type that in. Negative x squared plus 2x plus 11. Negative 2 to 3, 5 slices. Upper sum is 54. Lower sum is 41. Trapezoid sum is 47.5. Midpoint sum is 48.75. Simpson's rule is 48 1/3. And the exact answer is 48 1/3. And it repeats. Alrighty, questions? Number 4, okay. Where's the, oh, I forgot to put that 2 pages there. 25. Oh yeah, so this is the conversion of St. Paul. Monday. Got the question markers that are slowly dying, but I'll deal with it. So we get the formula x squared plus 2x plus 2. The first step is to graph this thing. And to get it in vertex form, you have 2 choices. You can either complete the square, or you can do the negative b over 2a to find the axis of symmetry. I did the axis version. So the axis is x equals negative a, b, c, negative b over 2a, which is the first half of the quadratic formula. So it's negative 2 over 2 times 1, so it's negative 1.
Markers.
So the vertex is going to be negative 1 comma something. How do you find the something? Plug it in. So negative 1 parentheses squared plus 2 times negative 1 plus 2. This is going to be 1 plus negative 2 plus 2. These cancel out. So it's going to be negative 1 comma 1. So the graph looks like this. One to the left and one up. And then we're going, it is a normal height, so you go over 1 up 1, over 2 up 4, et cetera, et cetera. 1, 2, 4, over 1 up 1, over 2 up 4. Don't know how much higher I need to go. That went from negative 4 to 1. I have to go one more space, I guess. 5, 6, 7, 8, 9. I don't want to obliterate my letters, so. This should be.
Oh, yeah, welcome to my pencil sharpener.
Yeah, sorry, Leo, Leo, okay, that's so
I
disruptive.
used up all the lead. I'm like,
I have one you can borrow.
I see.
Alrighty, try it out for some. Now, one thing you can do is mark these heights ahead of time. 4, 5, 6, 7, 8, 9. And this is a height of 10. So if you know what the heights are, you can do the upper sums without too much difficulty. Keep in mind, the upper sum is going to be different depending on which side you're coming from. So I see the heights as being 10, 5, 2, 2, 5. So it's going to be, it's 1 times 10, 1 times 5. If you'll forgive me, I'm just going to omit the 1 times, 1 times, 1 times, because it doesn't do anything. It's 10 plus 5 plus 2 plus 2 plus 5. So it should be 24. The lower sum should be the lower heights of each, which in this I'll be dotted line of these. So it should be 5, 2, 1, 1, 2. Is that making sense so far? Stop me if I bolt past it too fast. This is supposed to be 1 times this, plus 1 times this, plus 1 times this. These are the areas of the rectangles as you go by. So you either use the higher height or the lower height for each one. In this case, it's 5, 7, 8, 9, 11. Hope this is right. Forgive us, let me try it again. X squared. Well, not that I'm paranoid or anything, but yeah, I'm a little paranoid. Maybe 4 to 1, 5 slices. 24 and 11, nice. Okay, glory be to God. How do you get the trapezoid sum?
average.
You average the upper and lower sum, right? What is, whoops, what am I doing? 24 plus 11 over 2, which is 35 over 2. You can leave it like that, or it was 15, 17 and a half. Everybody good with that so far? Okay. Midpoint sum, this is the most aggravating one. You're going to find the height, like this is negative 1, negative 2, negative 3, negative 4, and this is 1. You have to find the heights of negative 3 and a half, negative 2 and a half, negative 1 and a half, 0 and a half, negative 0 and a half. negative a half. So you have to plug those in individually, which a calculator would be much, much more beneficial. I would say plug the formula in right away. It should be in there already. Y equals x squared plus 2x plus 2. Then they just plug in. This is, I'm going to be, let's call this up with x. What you're really going to do is this. F of negative 3.5 plus f of negative 2.5 plus f of negative 1.5 plus f of negative 0.5 plus f of 0.5. Ever see the principle behind that? I mean, I admit this is aggravating. And it's also 1 times this, 1 times this. Now, these are the heights when you go halfway through. So, I'm trying to make this really light and teeny. And I'll do a zigzag thing to keep it distinguished from the other one. Does that make sense? So the midpoint sum is you go halfway through the slice and find what the height is there. Let's see what happens. Oops, I just shut off my calculator a little prematurely. So if you want, you can call up the y1, go to the variables, y1, and then parentheses negative 3.5. I got 7.25 here. Then negative 2 point. And by the way, this trick of second enter comes in really handy. Then you can just scoot over and change the number. Negative 2.5. I got 3.5 here. And then negative 1.5 should give you 1.25. Then second enter, let's try negative 0.5. I got another 1.25, which kind of makes sense. Halfway through here and halfway through here, they're the same height. So this should give you the same answer. Plus, and then let's try 0.5. 3.25. Okay. So let's try this. Oh, yeah, that's kind of interesting. Maybe 2.5. Oh, this is supposed to be 3.25. It wasn't symmetric. It is. I just miswrote it. So add these up. I'm going to do the whole numbers first. 7, 10, 11, 12, 15. These are quarters. 15 and 1, 2, 3, 4 quarters. So 16.25. So we can make it 4, 1, 5 slices. So we get 24, 11, 17.5, 16.25, looking good. Tell me how to get Simpson's rule. Somebody? Second? It's a combination of these sort of guys.
It's the midpoint sum plus midpoint sum plus the droplet sum multiplied by 3.
Yeah.
Yeah.
So make sure the midpoint sum is twice as strong in your average. Count it twice. And then just take these numbers up above and do that. I'm going to write that as 2 of these, 16.25 plus 16.25 plus 17.5, all divided by 3. This is 32 and a half, 42 and a half, 49 and a half, 50. So it's 50 over 3. You can keep it like that, or you can write it as 16 and 2/3. And that's it. And now, the moment of truth. How to get the exact area? How to get the exact area under the curve? Yeah, just for the cork of the diagram. Use the antiderivative. And there's there's a special condition there.
Yes. That's going from,
I'll put this here, x squared plus 2x plus 2, parentheses dx, that's a normal antiderivative. What do you put in addition to that?
what's the two numbers?
Yeah, which two numbers?
Negative 4 and 1.
Yeah, it's going from -4 to 1. Where do I put the -4? On the bottom or at the top? I heard both answers. Which one? It's on the bottom, yeah. From -4, you go up as the numbers go up. From -4 to 1. So how do you actually do that? What do those numbers mean? First of all, can somebody do the antiderivative from? All right. You can do these individually.
1/3
1/3
x cubed
x cubed plus,
x squared
yeah, it's 2x squared over 2, which is x squared,
plus 2x.
2x, and then I'm going to close the brackets mean you already took the antiderivative. I would like, put these numbers as reminders over here. But, what do you do now? There's actually only one more step. What do you do with these?
Plug it in.
What's that?
You plug it in.
Plug them in. Which one first?
The one, the big one.
It was correct. You take the bigger one, which in this case is 1. So it's going to be 1/3 of 1 cubed plus 1 squared plus 2 times 1. Now what?
That minus
Minus
the equation -4.
the other one, exactly. In other words, if you want to get the distance between two things, you take the big one minus the small one. That's exactly what you're doing here. The further along thing, that's not a good English, but you know what I mean, minus the not quite so further along thing. But not so far along thing. I don't even know. Yeah, it's morning. -4 cubed plus -4 squared plus 2 times -4. And just as a quick bonus, you are welcome to type that in as you see it. Just for giggles, grab your calculator.
I brought mine today, but I left it in my bag with all my clothes
Why did you do that? Why did you put it there?
because I forgot to take it out. Yeah, it's unfortunate.
Now, type this in exactly as you see it. Just use big well, there's no such thing as big parentheses. Use a second set of parentheses for this. So paren 1/3 paren, well, 1 cubed. What do you do? You can skip over that if you want. So I did 1/3 plus 1 plus 2, close the parentheses, minus new parentheses. And this, yeah, I'm going to do, I wrote it like this. 1/3 parentheses -4 to the 3rd power plus parentheses -4 squared plus 2 parentheses -4 paren bracket. And I need to catch up with y'all. 1/3 parentheses 4 cubed plus parentheses -4. Don't forget the parentheses around the -4, otherwise you get the wrong answer. Squared plus, and you can do this in your head if you really want to. -8. And then close the parentheses. What'd you get?
Definitely got it wrong.
I made it 16.6 repeating.
Well, yeah, I'm still.
Oh, I see, gotcha.
What did I do wrong?
We've got, so 1/3 plus 1 plus 2. Okay, so that's good. close the last parentheses.
Error. Error.
Yeah, you can do second enter, it'll call everything. And then just put parentheses. Quite fine, that one. Do it here.
15.
Oh, it's up here. There's this one, Steve.
I think I have.
Yes.
Yeah, that's that one.
Delete that.
Oh, okay.
Ta-da.
Yeah, I got it,
Nice,
I
nice.
have way too many parentheses, I think.
Okay. So parentheses, one, so this one, one third, four third.
I got 15.
Negative 14. You like close. 16 by 66. Yeah, just second enter. So, yeah, go back to the beginning. See what we got here. So, okay, parentheses, 1/3 plus
I got 48 points.
1 plus 2. Nothing else is right.
I keep getting error.
Oh, when you say error, select go to, and it'll put its cursor where the problem
I don't know
is.
what I did.
Okay. Oh, this is -4, do -4.
Oh,
Try that.
11 points.
Oh, I'm on track, that's a number, see? So 1/3, plus 1 plus 2. Do second enter and it'll call the units back up. There you go, now you can scroll back up. And 1 plus 2, and then 1/3 -4 cubed. And you can do inserts. Oops, parentheses there. And then, yeah, power 3, I'll delete the extra parentheses. And then plus 2 times -4, try that. 30. You get a parentheses. Oh, 2 times -4 at the end. -4 plus. Oh, you've, oh, I see. This is supposed to be -4 squared. Plus 2 times -4. There you go.
Oh, lordy.
Now, yeah, tedious. By the way, go to the math menu on your calculator. It's on the left-hand side. Everybody find it? It's on the left-hand side, right below alpha. The very first choice is what? Select it. Hit enter. It converts your answer to fraction. Yeah, it's 50/3. So if you need it as a fraction, ta-da, there it is.
So useful.
Now, we know where it is now. So, questions? I realized this was a pain in the backside to type in, but the principle is take the antiderivative and take the bigger, sometimes it's bigger, the further along number, that like the last number minus the first number. Plug in, and subtract. Because that's how you get the difference between, like, from how far is it from 5 to 12? Is 12 minus 5. It's sort of a distance formula. That is called the what theorem? Does anyone remember?
First fundamental.
The first fundamental theorem of calculus. Correct. Calculus, integral calculus would not exist without this. So it's fundamental, like very, very important. Questions?
Why do we have to do all the other 5 steps if we can just get the answer?
Part of the reason is, the only reason we can do this is because this antiderivative is easy. I mean, not fall off a log easy, but easy. So if somebody gave, there are some functions where you just cannot find a formula for the antiderivative. It's impossible. So I'll just think of one off the top of my head. The integral of x times sine of cosine of tangent of x plus pi x all over radical secant squared of x plus 5 dx. there is no one on earth who can do that on paper. Is this thing just does, as far as I know, does not have what they call an elementary antiderivative. In other words, there is no possible way, you could get a formula for that. So you have to use these. And by the way, I would probably not use these because they're relatively slow. I would jump right to Simpson's rule. It's the most accurate one. And as long as you have a computer doing it anyway, which, yeah. If you're on a desert island with no computer, yeah, you can do upper sum. Yeah, I would. I might do trapezoids, I'm just getting off picky. But if you have lots and lots of slices, upper sum is fine. But if you have a computer doing it anyway, and you can't do an antiderivative, do Simpson's rule. Because that's actually what, I showed you that on Friday, when your calculator did the antiderivative for you. Just for giggles, let's try that. Go to the y equals screen. Is the formula still on there? The x squared plus 2x plus 2? Okay, good. Quit out of that, and go to second trace. That'll be the calc menu. Look at number 7. Should look familiar. Select it. It should graph it for you, which is kind of nice.
I'm sorry, I'm on my board, which.
Oh, okay. Go to second trace. That's the calc menu. The calculate menu. And then you go to choice 7, which is antiderivative. And it should graph it for you. If the graph is looking weird, let me know. Because that means there's a weird zoom setting.
We're supposed to do second trace,
Second trace.
and then we'll look for it.
And then go to choice 7. And then it should graph it and then ask you a question. What's the first question it's asking you?
Lower limit.
Lower limit. What would you say? -4. Type -4 and hit enter. Now what's it asking? Upper limit. What do you do? Type 1 and hit enter. And the graph actually looks kind of cool. It shades it in for you. That's the area it's representing. What is it saying?
16.6.
16.6 repeating. All right. It has a 7 at the end just because it's rounding off, but it's not supposed to. That, by the way, is it possible for the calculator to do it for you? Should I tell you this or not? All right, fine. The short answer is yes, but this is meant to, A, this is meant to check your answer, and B, this is not infallible. What the calculator is doing when you ask it to do it for you is Simpson's rule. It's doing lots and lots of slices of Simpson's rule. It does like, instead of 5 slices, it does like 5,000 or 10,000 or something like that in a very, very short period of time. If you'd be so kind, this is going to be coming up more and more. Go to the calculator and hit the math menu. We had gone there before for converting to fraction. But I'd like you to scroll way, 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 way down to choice 9. It takes a little bit of getting used to learn how the format of this goes. Did everybody find something looking like this? FNINT. Now, if you have a newer calculator, it's just going to do this. If you have an older calculator, it'll put the letters FNINT on the screen. Go ahead and hit enter, if you haven't already. Oh, you have the newer one, okay.
No, my board.
Yeah, mine is old too. Good. FNINT. The newer people, you actually got a bonus here. All you have to do is use the arrow keys and put this stuff in where it needs to go. Put a -4 in the bottom boundary, put a 1 in the top boundary, and then type this stuff in. It does need to know what variable you're using, because it is such a thing. We've seen dy's and dt's and d thetas. It wants to make sure that you're doing dx. As soon as you're ready, entering all that in, people in the new, hit enter. And it should give you 16 2/3. People on the old calculators like me, here's what you have to do. It's going to be formula, comma, variable, comma, min, comma, max. In other words, this is the formula. This is the variable. You'd have to type x. And use the comma key in between. That's the thing right above 7. And I apologize for the comma key wore off on my calculator.
Do we just put X?
I've been using it for so long. There's that comma key right above 7.
Two variables, we just use X?
Just use x. Correct. And then comma, -4, comma 1. Close parentheses, hit enter. Okay. The advantage of doing that, when you do it on the graphing screen, you have the satisfaction of seeing the graph, but you can, in case you get something gucky, and you're saying, wait a minute, is that fraction? Go to the math menu and convert that to fractions. You'll be able to get the exact answer in fraction form. Make sense? Okay. That's going to be more and more useful as the year goes on. But for now, and for those of you listening at home, hi Jonah, we just, hopefully, I don't know which kind of calculator you have. You might have the fancier one, which would just look like this. This is math menu, choice 9. And it'll give you a thingy to fill in here, thingy to fill in here, excuse me, thingy to fill in here, D, and then the thingy to fill in here. You would put -4, -4, 1, x squared plus 2x plus 2, and then an x here, and hit enter. And then if you need it in fraction form, go to math, the very first choice, convert to fraction. Okay? Any other questions?
Like a problem?
Yes,
Can we do 5?
we can do 5. Hang on a second. Everybody get number 4? At least, I mean, I'm not talking about, psychologically in love with it, but. Now, the first battle is to get this thing graphed.
Yeah, I know.
Or
The
you
graphing on
one-
this is a little
or you
aggravating.
get like one number off on the
Uh-huh,
min or max and you're done.
I hear you. So y equals -x squared plus 2x plus 11. So I'm going to do the axis of symmetry thing again. -b over 2a, which is -2 over 2 times -1, which is -2 over -2, better known as 1. So the vertex is 1 comma something. What's the something? I don't know. Let's plug it in. Negative, parentheses, 1 squared, plus 2 times 1, plus 11. This will be, 1 squared is 1, times -1 is -1, plus 2, plus 11. This is 11, 12, 13, 12. So 1 comma 12. So you have to go up to a height of 12 to graph this thing. Here we go. So 1 comma, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. This is the vertex. And if you notice, the height multiplier, this is pre-calc, or actually second year algebra. The height multiplier is -1, so it's the normal height, but going down. So instead of over 1 up 1 over 2 up 4, it's over 1 down 1 over 2 down 4. Let's do that. So that's mark these two. So over, and this is, darn it, what was it again? Height of 12. What interval do they want? From -2 to 3. Okay. So over 1 down 1. Over 2 down 4. This is the height of 11. 10, 9, 8. Be down to a height of 8 for the next one. This is as far as I need to go on the right hand side. From -2 to 3. And do one more for -2. Over 3 down 9, which will get you down to a height of 3. So it should look like this. Let's keep going from there. So we need the area under the heights are dealing with the 3, 8, 11, and 12. So the upper and lower sums will be using those. Let's try it. Yeah, yeah, thank you. I'm sorry. Okay. Upper sum. Now again, if these slices had been a different width, I would be like, if these were always 2 inches thick, I'd be doing 2 times the first height, 2 times the second height, 2 times the third height. Does that make sense? For the rectangles? I'm just doing, I'm not even writing the ones because they're not doing anything. I could do 1, but it's 1 times the first height plus 1 times the second height, and the ones don't do anything. So the first slice is going to be a height of 8. Let me see that? From the negative 2 to negative 1 slice, it would either be 3 or 8, and you take the higher of the 2. So it'll be 8. What's the next height? Somebody tell me. 11. Keep going. 12. What's the next one? Another 12. And then another 11. Good. So it'll be 24, 34, 44, 46, 54. Okay. Just because I'm paranoid, that's wrong. So we've got negative x squared. That's 2x plus 11. Yeah, we get back to math already? Wow. There we go. No. From negative 2 to 3. 5 slices. Yes. Upper sum is 54. Can somebody tell me the lower sum? What's the first lower sum? 3. Keep going. 8. 11. 11. 8. Good. And these should add up to 22, 30, 38, 41. Nope. Yep. This guy here. Welcome to my life. Drop side sum. How do you get that?
Average.
Yeah, average those two. So 54 plus 41 over 2. So it's 95 over 2. You can leave it like that if you want, or it's 47.5. The midpoint sum is aggravating. You're going to get the heights, individual heights. Let me just put the answer here. 48.75. Remember this by hand. We've got, all right, I'm going to break this. Great. So what is the very first height you use? Y1 parentheses what? For midpoint. What do you plug in to get your first height? All math people. Here's your first slice between negative 2 and negative 1.
Negative 1.5.
Negative 1.5.
The disappointment.
There we go. So the height of, let me just put this here. F of negative 1.5 plus f of negative 0.5 plus f of 0.5 plus f of 1.5 plus f of 2.5. And you're going to get, I got the first one is 5.75 plus 9.75 plus 11.75. And I suspect the next one's going to be 11.75. Yep. Anyone want to predict what the next one's going to be? Since they're mirror images on the other? 9.75 now. Oops. And that should be 48.7. Yeah.
I think I'm just like very confused on the midpoint.
Okay. Let me just do a different graph on this. Let's just say this is some sort of mystery function f of x. And let's say this is -2, and this is -1. Like, this height, how do we get this height? You plug in -2. Does that make sense? When you plug in the x, you get the y. I would call this f of -2. Then to get the height here, I plug in -1. So if you want to be fancy, you could say this is f of -1. The midpoint sum formula says go halfway through and use that as your height. So instead of plugging in -2 or -1, you plug in -1.5. That's how you get the height for this slice. It's not going to be exactly halfway, but it's close.
Yeah.
If it were a line, it would be exactly halfway, but this would be f of -1.5. So you do that, go halfway through the slice, use that height. Go halfway through the slice, use that height.
So then in our calculator, we use the y1
Right,
and then plug it.
correct,
Okay.
right, no problem. Any other questions on that? How do you get Simpson's rule? Right, midpoint plus trapezoid all divided by 3. So average 2 midpoints and 1 trapezoid all divided by 3. And I forgot what that was, but type like 8 million things in between. Now it's just going to be -2 to 3, 5 slices, 48 1/3. 48.3 repeating for Simpson's rule. And the exact area is also 48 1/3. I can show you that by hand. That would be, actually you tell me, how do you get the exact area again? Antiderivative. Here's the formula. Can somebody give the antiderivative for me? Spell this regular out for me. Good. X squared. What's the antiderivative of that? Yeah, right track.
11x.
11x. Does that make sense? Technically, there would be a plus c here. When you actually plug it in and subtract, you don't need the c. Remember why not? They cancel, right. It'll be c minus c. It'll be blah, blah, blah plus c minus blah, blah, blah plus c, and the c's will cancel. So what we need to do is take this piece and enter the two boundaries from -2 to 3. Which one do I enter first? When you do a subtraction, what do you want to put first? Yeah, the further along one, the 3 in this case. Let's try this thingy. -1/3 times 3 cubed plus 3 squared plus 11 times 3 minus what? -1/3 times what? -2, yeah, the lower one. Cubed plus -2 squared plus 11 times -2. Now again, mental math can really help you here. You can actually do it faster than typing it into a calculator. And as you've probably noticed, getting the parentheses right and putting everything in the right spots is sometimes more of a nuisance than doing this in your head. 3 cubed is 27. 1/3 of that is 9. -1/3 of that is -9. Plus 9 plus 33. Nicey, these cancel. So this is 33. Minus 3. Now here, what's -2 cubed? Oh, math people. -8. So -8 times -1/3 should be
8/3.
8/3. Plus, what's this?
-4.
4, could say, plus
-22.
-22. Now I will need to count the denominator over here. But if you, I mean, if you're talking about typing it into a calculator, which by the way is forgivable at this point, if you're doing a bunch of these, you might notice time is of the essence. So if you get it down to this level, I would do these in our head. This is like -18. If you want to type this in, 33 minus parentheses 8/3 minus 18, you can do that. It'll save you a little bit of time. I'm going to do that. 33, whoa, 3. So 33 minus, don't forget the parentheses, 8/3 minus 18. I get 48 and 3 repeated, which is exactly what we want. Does that make sense? Alrighty, tell you what. I have another worksheet for you, and Joan, I'll email a copy of this to you. We're not doing the whole thing, no problem. We're just doing part. At least partially because I haven't given you notes for the other part.
Holy smokes.
I have not shown you how to do 7, 8, 9, and 10. So what I would like you to do, actually just for today, I would just like you to do 1, 2, 3, and 4. That'll be for tomorrow. So do not do 5 or 6 unless you're really feeling courageous or into self-abuse. So 1 through 4. On homework 5L-2. I'm going to give you a little bit of a hint. Number 3 and number 2 and number 1. 4 is actually relatively tame. Number 1, 2, and 3 are not in what I would call antiderivative friendly form. I would like to do at least one of those with you up to a point so you can get the formula. Any suggestions? Which of these would you like to attack? Which one looks the most scary? What's that?
Likely number 1.
Number 1? Sounds good. So you've got the antiderivative from -5 to -4 of this thing. By the way, you see that negative in front? I'm going to put that up on top because it's really hard to see. It's really easy to miss if it's stuck in the front. It looks like it's part of the bar. X plus 3, parentheses cubed, dx. This is not an antiderivative friendly form. I would strongly suggest you do this. From -5 to -4 of -3 parentheses, what?
X plus 3 for negative,
Yes. That will work much better. And by the way, you see this -3 in front? Guess what you can do with it?
you know,
You can take it out. Just pull it in front and not trip over it. So it's -3 times the antiderivative from -5 to -4. This is called the definite integral because you're definitely getting an answer of x plus 3 to the -3 dx. Now, how would you have done this problem earlier in the chapter? Like, pretend you don't even have the boundaries. How do you do something weird like that to the -3 power? What should I suggest to you? If you have something weird, if the heart is icky, what? Substitution. U equals what? X plus 3. What's du? It's actually pretty boring. 1. 1 dx, or just dx. Make sense? Is that lying around anywhere? Yeah, it's sitting right here. Rewrite this for me. The -3 is in front. Just do this for a second. U to the -3, and what is this? It's du. There's just one catch. You can do this, and it'll actually make your life easier. But do you see these numbers here? These were values of x. I no longer want values of x. I want values of what? Of the letter u. Any bright ideas how to do that? It's actually easier than you think. If x is -5, what's u?
Be -2, -1.
Plug it in and find out. Yeah, -5 plus 3 is -2, and then the other one is what? -1. Exactly. So, what's that?
So then you plug it over.
Right. Now, do the antiderivatives. You can act, the nice thing about this is, once you have everything transferred over to the letter u, you can actually do the problem and forget about the x's. You never have to plug it back in. As long as you're just getting a number answer, believe it or not, this thing will almost magically do it for you. Yeah.
Are we, this homework, what exactly do we have to do?
Find an answer. Find a numeric answer of 1, 2, 3, 4. Like find the exact area of the curve, if you like.
So we have to plug in the top and then subtract it by the bottom?
Correct.
Oh, okay, we're not doing like upper sum.
We're not doing upper sum, lower sum.
Exactly.
Correct. This is just find the exact area, period.
Okay, so that was like F on the worksheet?
Correct.
Okay.
Correct. And that's the only thing you need to do. Actually, what the heck? Let's keep going. Like this word.
Okay.
So what's the antiderivative of u to the -3? Careful here. Raise the power.
No, wait, so -2.
U to the -2. Good. A lot of people put u to the -4 by mistake. Divided by to the new power plus c. That's going to cancel, by the way. But it's going to be from -2 to -1. But if you want to just throw away the c, feel free. It's just going to cancel anyway. By the way, that's only true when you're getting a definite answer. If you're doing an indefinite integral without boundaries, you need the plus c, because it won't cancel. Someone want to try it? What is this thing? It looks kind of messy.
It's number 1/2.
Yeah, it's -1/2 times u to the -2. So what is that really? What is u to the -2?
U.
U squared in the basement. -1 over 2 u squared. Exactly. Nice. From -2 to -1. So what do you plug in first? The -1. So it's going to be -1 over 2 times -1 squared. That's the first plug-in. Minus -1 over 2 times -2 squared. Get it? What is this? What's -1 squared? 1. So what is this? The whole thing. -1/2. Okay? Minus something else. What's -2 squared? 4. So what is this whole thing? -1/8. What's minus a negative? Positive. So it's, this was, so -1/2 plus 1/8.
3.
We need a common denominator. So it's -4/8 plus 1/8, better known as -3/8, and you are done. You might say, how can you get an area under a curve that's negative? I'll tell you that tomorrow. The short answer is, if you have area, like you have a function that goes like this, and you try to do that, if something accidentally goes underneath, it's treated as a negative area. That's kind of what happens there. That make sense? So there's your first answer, -3/8. And then try your best. By the way, you should be able to use your calculator to check your answer. Don't do your answer, but check your answer. You can use FNIT or you can use the graph. I think that's it. And we're just about out of time. Please stand. In the name of the Father, of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. See y'all later. See you in a few minutes. Take care, Jonah. See you soon.